There's a lot of value in SolidWorks Premium. One of those items is in our validation tools that we offer with SolidWorks Motion and SolidWorks Simulation. They really help us to evaluate our designs to see if they're going to operate the way we want, as well as making sure that they're strong enough to carry the loads that our design needs. Here's an example where we've got a mechanism for picking up a concrete pipe segment. The mechanism goes down into the hole and then using a wedging action lifts it up automatically. We then have a linkage system here to then release it later on. Let's take a look at how we do that very quickly. We have our assembly of components. In our motion tool, all we would have to do is to set up a couple of things. We've got gravity. We've got an actuator which is going to lower our tool down and then pick it back up. Then we've got some contacts to define how those parts interact. For example, we're dealing with friction, which is how the wedging effect occurs. So we've got our contact between the arms and the pipe to represent that. And then once we've finished raising and lowering the pipe, we just retract these arms, which is, in most cases, I'll use a chain to then pull this up to release the component and then run the analysis. So let's have a look at that. So we'll see here that the system comes down, it hits the edges of the pipe and folds up a little bit. And then as we pull back up, the parts wedge out into the pipe and then based on friction, pick it up. And then when we lower it down again, we just raise up that collar which lifts the arms up and takes them out of contact to release it. Now SolidWorks Motion and SolidWorks Simulation are so tightly integrated, it's really fantastic. We actually have the ability to validate a design straight inside SolidWorks Motion. So in this case, after we've run our motion simulation, we can let it calculate the results at all those time steps. Now I've already done that, it takes a few minutes to run, but we can look at things such as stress, deformation, and factor of safety. So all I'll do is just hide this out of the way so we can see what's going on. So here's our design, and we'll just make our little load actuator plot a little bit smaller. But again, this is something else. With our actuator loads here, we can obviously size how much force it's going to take to lift up this pipe segment and make sure our things are strong enough. Now the value of adding simulation into motion is that we can now take the loads automatically from our motion model and check the strength of our components. So we can see here, we'll see it get loaded up as we clamp onto the pipe and lift it up. And then once we bring it back down again and release the arms, you'll just see the load localized area where we're lifting up on the tool. So it really takes out the guesswork in knowing how to restrain our system and what loads to apply. We take that automatically over the entire time frame and we get that for our model. This is just one example of the capabilities we have in simulation. For more information, please contact your reseller to get additional data.